Good afternoon. I'm Arun Seraphin, Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. I'm very excited for today's webinar about the case for robotic welding in naval shipbuilding. For those of you who don't know us, ETI, the Emerging Technologies Institute, is an affiliate organization within NDIA, where we focus efforts on building the government-industry dialogues and partnerships that support defense innovation. We do this through a variety of events, including our Fall Emerging Technologies Conference, reports and webinars like the one we're holding today, and podcasts and other educational activities. I hope you'll visit our website and YouTube channel to experience the whole range of our activities and products. NDI has many activities that are helping shape the industry-government partnerships to create the defense industrial base of the future, this webinar being just one example. I also recommend that you track the work of our many technical divisions, including our manufacturing division and our undersea warfare division and our procurement division, as well as our soon-to-be-released vital signs report. See more of our efforts to support the nation's defense industrial strength. In trying to build the naval forces of the future, the nation requires a strong industrial base, including, of course, in shipbuilding. Today, we're going to look at one of the pieces of the shipbuilding process that can sometimes be overlooked, namely welding. In thinking about shipbuilding and manufacturing challenges, automation represents a potential pathway to alleviate workforce shortages and schedule delays. The report we're going to talk about today draws on an industry survey, expert interviews, and a technical review to develop a comprehensive business case for robotic welding. The report also addresses how to overcome key financial and regulatory barriers and provides recommendations for the Navy and industry to better integrate robotic welding into shipbuilding processes. We'll first have a presentation of the research that inspired this event, and then we're going to hear from an expert panel about their perspectives on robotic welding adoption. Some administrative remarks before we get started. One, all attendee lines are muted. Second, if you have a question during the webinar, use the question box, not the chat feature. You can ask questions anytime during the webinar, and our moderator will hopefully get through them at the end of the presentation. We are recording today's webinar for members unable to attend. Before our panel, we're going to hear a presentation from the research that inspired this event from Dr. Eunice Balogan. Eunice is an engineering manager with the Naval Sea Systems Command, NAVSEA, Ship Integrity and Performance Engineering Group, where he focuses on the fabrication and repair of surface ships, submarines, and machinery applications. He's a licensed professional engineer with a PhD in metallurgical engineering, and he's provided critical materials expertise for Navy programs for over 15 years. And most importantly to me, recently completed a public-private talent exchange fellowship with ETI. This public-private talent exchange, or PPTE program, has been a great benefit to ETI and NDIA and provides another avenue for government employees to strengthen their experience with and knowledge of industry and industrial partners and their strengths, incentives, and challenges. I strongly recommend the program to any individuals or organizations who want to explore a new way to interface with industry. During Eunice's great time with us, his main focus was working on this report, which then led to this webinar. We thank him for this and all his other support for ETI activities. We hope that the report and the webinar are just the starting point for the dialogue we need to see that government and industry can take full advantage of this promising technology area. With that, I want to once again thank Eunice for all his help at ETI and turn the proceedings over to him.
Thank you. Thanks, Dr. Seraphin. Today's presentation is about robotic welding for naval shipbuilding. So, as Dr. Seraphin mentioned, this came about from my 5-month ETI fellowship. So, this report has been published in December, and it's available for free download at the link at the bottom of the screen. So I just go straight to the presentation. So the state of naval shipbuilding is not at its best. It's in a very strained state with Actually, in the Maritime Administration in 2021 published a report which stated that since the 50s to present time, the current shipbuilding output in the US has declined by about 85%. So this is even considering the fact that budgets have doubled over the past 40 years, and for naval shipbuilding, the still struggle to meet the Navy fleet demands or requests. So to worsen situation, there's also a projected shortfall of about 330,000 skilled welders in the next 2 years. So it's a very dire situation. Looking at the global landscape in shipbuilding, the Asian powerhouses of South Korea, Japan, China, they look at automation as part of infrastructure development. And as a result, they are really aggressively integrating robotic welding into their shipbuilding plans. And it's only recently that the US started moving in the same direction, but we're still way behind. So over the years, welding for shipbuilding is a critical part of the overall structure of shipbuilding. Manual welding accounts for about 25 to 28% of labor hours and about 28% of manufacturing costs for a ship in current day terms. So why is it so expensive? Part of it is related to the low arc on time for manual welding, because how much time the welding touch is actually on is active is affected by human fatigue, and also this is also a hazardous environment. The weld environment has some hazardous elements in the weld pool. So all this affects how much you can really get out of the system. So we tracked industry process in terms of how well they are progressing with welding automation. Looked at 2015 NSR, that is Naval Shipbuilding Research Program survey, which looked at 7 shipyards in the US. And they found that some of them were 100% manual welding in their processes, while a few of them were about 90% automation. And coupled with the fact that we now looked at the current situation in the NDI survey of last year, it kind of gave a sampling of the same situation that was the NSRP survey indicated, which is only about more than 60% of organizations are still at either not using robotic welding or very minimal use of robotic welding. So far, only about less than 15% are actually making extensive use of robotic welding or just moderate use of robotic welding. So this situation has not really improved over the years. Question is, how well are other industries outside of shipbuilding doing in terms of robotic welding? So we looked at the business case. What benefits did other sectors in the economy using robotic welding? What do they see? What advantages do they really see? So in terms of cost reduction, John Deere, which is a heavy equipment and machinery manufacturer company, achieved about 35% reduction in labor and operational costs. A shipbuilder, Fincantieri, which currently building FFG 62 and 63, saw a 90% reduction in welding consumables, and were able to reduce their power consumption by about 60%. Now, MDS manufacturing, which is another industrial equipment manufacturer, was able to get about 20 to 50% improvement in efficiency. Caterpillar and AGCO, which is an machinery company, realized a 15 to 20% reduction in scrap, in costly scrap and reworks. Only last week, a company, FMD, which is a defense company, can't remember the exact name. They reported about 75% reduction in engine repair costs, in labor hours for engine repair. Kubota, which is an agricultural machinery, and Boeing, which is aerospace, reported a 40 to 50% reduction in welding-related workplace injuries. So by applying robotic welding, you're able to direct skilled workers to welders to other high-value work and reduce labor and be able to mitigate labor shortages, which is currently a problem. So what is the business case? What is exactly holding us back if truly there are benefits to robotic welding? So the survey reports showed up some issues which organizations in the welding industry, in the shipbuilding industry, identifies as barriers. Number one is high cost of entry, as well as the fact that they can't really determine, analyze what the return on investment will be if they adopt robotic welding. So without actually buying the equipment, using it, they can't just easily analyze what the return on investment will be. And reason being that robotic welding is not, most of the return on investment models are based on current traditional welding techniques. So qualification and certification, it was also another high barrier which that was brought up. Some of the organizations mentioned that it takes quite the time it will take to actually qualify a process would eat up any advantage they get from the benefit from robotic welding. Now, the third was workforce. So to deploy robotic welding, you need just more than experienced welders. Then also you need welders who have very good programming skills too to run the system. And also the fact that there are technical and integration challenges. For instance, there are many OEMs who sell equipment in the for robotic welding, and having to integrate all the various disparate equipment is a challenge without having to lock into just one OEM supplying all your robotic equipment. So what is a solution to all this, some of the problems raised, or majority of these problems raised? So technology is advancing to kind of help in taking care of some of the challenges, some of the barriers raised. For instance, for poor fit in welding, new vision systems and laser scanning have been able to enable real-time adaptation of the welding touch as you are welding. AI-driven welding, AI-driven in-process quality assurance is also helping, as well as post-weld inspection. So these are all part of the quality system. And then you can improve robot uptime on the shop floor by taking advantage of offline programming and the use of digital twins. And for those looking at entry points and not have to spend significant amounts of money, cobots are not less expensive for those looking to start using robotic welding. And then because NSRP in a study recently, not too long ago, found that about 45% efficiency, greater than 45% efficiency was realized by using cobots. And then next, we came up with some recommendations to kickstart adoption and demonstrate feasibility while generating initial return on investment and data. So we had some actions for the government and some for the industry. For the government, we recommended a robotic welding pilot program. So the Advanced Robotic Manufacturing Institute has a program where they currently work with organizations to train them on and help them analyze return on investment for robotics applications. So having programs like this and also can de-risk initial investments for those looking to deploy robotic welding. Also recommended having regional demonstration centers by partnering with organizations such as the Cobalt Alliance. So the Cobalt Alliance already has worked with shipbuilding organizations to demonstrate new technologies and also help with training. And also the qualification process can also need some modernization by taking advantage of simulation as well as in-process data that come out from testing that is ongoing. For the industry, they can start small and not have to spend significant initial amounts of in capital. They can use robots for very repetitive tasks and gain confidence through that. And then they can also collect data, which can help with qualification down the road. A strategic roadmap, we had a three-phase approach. Phase one is kind of foundational, in which the government can launch the robotic welding pilot program, as we indicated, to de-risk initial shipyard investments and also prove the return on investment. And industry can deploy pre-engineered cells. The certification process can be modernized by using in-process data. The phase two is scaling up, which is 3 to 7 years time frame. So this, you can expand robotics not just from just simple parts to actually going to use them for building complex structures as well as hull assemblies. And you can standardize some of these procedures across the entire industrial base. And the last phase, which is the hyper-automation in time frame of 7 to 15 years or less, deploy actual autonomous robots for large-scale independent welding. And then at this point, try to actually integrate digital twins such that from initial design through production, you can actually have everything in one. You can actually simulate the whole process and automate it. And lastly, the bottom line is Naval Shipbuilding is at a critical junction, and there's significant vulnerability in the system. So robotic welding is not just a readiness issue, but also a workforce as well as a capital-intensive issue to look at. So there are already technical solutions available or in the pipeline, and most of the barriers are either organizational or policy driven. So there is need for coordination across industry and government for success, and this is a very important national security imperative. And thank you. We hand it over to the moderator, Mr. Segerstrom, to take it from here.
Thanks, Eunice. This is Arun again. Thanks, Eunice, for a great presentation. I want to invite our moderator, Jim Siegelstrom. Hey, Jim, to join and moderate this expert panel. Jim is the CEO of McNally Industries and the chair of NDIA's manufacturing division with over 35 years of managerial experience in manufacturing and distribution of industrial equipment and defense products. He's been a great partner to NDIA and especially to ETI for a long time now. I really appreciate your support for this effort as well. Over to you, Jim.
Thanks, Arun, and thanks to Arun and the entire ETI team, as they always do such a great job in tackling these emerging technologies that are trying to find their way into the defense industrial base to improve on our workforce capabilities, our warfighting capabilities, and all the things that are related to making sure we can stand up a strong defense. So we have our panel, and I'd like to introduce them. And as I do introduce them, I'd like to have them, as they give a brief intro on themselves and a brief bio, consider and provide their overview on the current state of adoption of robotic welding, as well as where they've seen the most significant impact of the adoption of robotic welding. And our panel today consists of the supervisor of welding engineering advanced concepts team from General Dynamics Electric Boat, Mr. Vincent Mangino, the principal engineer for ARM Institute. For those of you unfamiliar with that, that is the Advanced Robotics for Manufacturing Institute under the Mantech MII system, Mr. William Miller, and Eunice will also be participating in our panel. So if you guys could share a little bit on yourselves and an overview of robotic welding along with where you've seen smashing success. Thank you. Let's start with Vincent.
Hey, thank you for the introduction, Jim. So my name, like Jim said, is Vincent Mangino. I've been working at Electric Boat now for almost 11 years. Over the past probably 10 years, been pretty heavily involved in robotic welding. We've definitely had some good successes. We've definitely had some struggles. I think the presentation that Eunice just gave definitely harped on a lot of those. Looking forward to some of the questions that we get today. But you know, the biggest lesson learned from all the robotic stuff that we've had is being sure that you have a defined business case prior to just, let's call it, automating at all costs. So we've welded everything from thinner structure, which for us is around 1/2 inch, all the way up to about 4.5 inches, 5 inches with fully robotic processes.
William?
Yes, thanks for the introduction, Jim. William Miller, Principal Engineer at the ARM Institute, the technical lead of our Robotics Manufacturing Hub, which is effectively a small robotics de-risking center where we help manufacturers adopt robotics and automation, from welding to grinding, part handling, just to get them into the door and help them understand robotic adoption, taking all the risk out of that. On the welding side, obviously, anything that is high volume, low mix really has a lot of value in robotic welding. But we've really seen, with the change in technology over the last few years, a move towards more of a low mix success with the ability to reprogram robots rapidly offline, and a lot of the onboard closed loop welding technologies that can really help in that low mix environment.
And Eunice, did you have anything you wanted to add? I know.
Yeah, Eunice Balogun, NAVCO5P, and I'm an engineering manager for materials welding and fabrication. work with the shipyards, the regional maintenance centers, and we help them with procedure qualifications and issues with welding and the specifications that they use. We also look at new technologies and qualify them for use as well.
Thank you. And on to the questioning. We're going to direct the question somewhat, but obviously any of the panels are welcome to chime in on any of the questions. We'll start with William. Question number one is according to ETI's report, more than 60% of surveyed organizations report minimal to no use of robotic welding. Given the success in other heavy industry, what is the created naval shipyard building resistance to automation thus far?
Yeah, no, that's a good question. And there's really two facets to this that I'll speak to. And the first one is technical, and the second one is, of course, on the workforce. From the technical side, there's really minimal overlap between the established robotic welding applications, for example, automotive, with the shipbuilding process. And I think that's really been the fundamental delay point and why robotic adoption has been a bit slower in the shipyards. As we know, robotics have been used in other industries, automotive, for decades. It is high volume, low mix, tight tolerance, stamp parts that are fundamentally designed for automation. You have standard joint types, you have constant, consistent material thickness. And shipbuilding is pretty much the opposite of that. You really have a high mix, low volume weld joints, large plates, limited fixturing, plates that can warp, misalign over the weld time from heat distortion, minimal access, confined spaces, you name it. The environment, you're outside. Really a lot of differences on the technical side between established welding and the ship on the ship side. So I think that's really played a major role in this. And you have the workforce as well. It requires really a change in culture, which can be really met with from a variety of resistance of human responses. To some degree, people can view it as devaluing the work. Welding is a hard-earned art skill that folks take a lot of pride in. So it's kind of hard to pass that skill off onto a robot. Job security is obviously a concern. And then you have the education side as too. How do you educate the workforce and make them comfortable in operating, programming, and everything else?
Did anyone else have any comments on that?
Yeah, I just want to add one thing here. First, I'll address the little comment in the chat. I'm not allowed to show my face because of my company's IT requirements, so I apologize for that. But William, you said it very well. The shipyards are not real. Shipbuilding is not made in a way that it's not like, you know, Ford's panel line for F-150s. It's not making 100 cars a day or however many they make, right? You're talking 1 or 2 ships a year where, you know, there's a big shortage of material right now. So you can define the best sequence to go do that. But if you get material at different times, your sequence then has to change. And so it's a very, like you said, low mix, high volume, where schedule is constantly changing and driven by things that are outside of the welding control, right? And I think another big point you mentioned, which is important, is the fit up, making sure that the material comes and has those low tolerances. You know, you hit on all the good points. Operator proficiency with the systems. There are systems that have been coming out in the past year, 2, 3 years that are allowing for that user interface to be more simple. But a lot of the time, the experienced workforce, they get frustrated when some of these user interfaces, like if you look at the original ABB user interfaces where you're literally typing code, that's a skill in and of itself, and you need a lot of education on that. But now there's a lot more user-friendly tablets that are helping get there. But I think there is still a level of frustration and education that needs to be had on top of, you can't just trust the robot to do the job, right? You can program a bead that looks beautiful, but if you don't even put it in the joint and you don't really know what you're looking at, well, then you're still not doing great work either. So all those things have to be considered.
Thanks for that. And Vincent, this one is directed your way for starters. One One obstacle noted by report interviewers was the robotic welding qualification time can exceed any potential schedule savings from automation. How should current qualification processes for welding adapt to advancements in robotic welding? And what is the best approach to balancing innovation and safety?
Yeah, so there's a lot of different things I think that the industry can do. We'll start with qualification. I could really only speak to the work I've been involved at Electric Boat, which is all predominantly submarine work. We have been in lockstep with NAVSEA and the Navy labs, really working towards streamlining the qualification process. We know, as Eunice had said, qualification requirements can be more modernized and be made better, but I think you could say that about any requirement at any time. There's always room to get better. And I think the work that we've been doing with NAVSEA and the Navy labs has been really, really valuable in streamlining that qualification. I'll give one simple example that I think has probably been a big hurdle. It used to be that you'd have to get a specific robot and you qualified on that specific robot for the procedure, and you had to qualify all the operators on that specific robot. If you have a high volume of work and you only have one system doing the job, now you have to either qualify operators or be welding production parts. So how can I maybe get a similar robot that's more of a qualification type cell to train all my operators on that so that they can constantly be running the systems out in production, right? And so that's something to consider also. The shipyards want probably a large number of robotic systems. It's more than one, whereas, you know, a mom and pop shop may only need one. So there's pros and cons, and I think the scaling of robots really needs to be considered. And then to answer the second part there, what is the best approach to balance innovation and safety? I want to hit on safety, right? So safety really should be and is the shipyard's number one concern. I was recently heavily involved in the past few years of developing a robotic cell that got the operator out of a very high temperature tank while doing the welding. So in that regard, the robot was able to do all the manual tasks that a human would do, but then also increase the safety of the cell. Because how great would it be, you know, to not be fatigued, sitting in a chair behind a console, right? So those are the types of things and the types of applications that should be gone after to go see which would be best for welding and for robotics.
Did anyone else have any thoughts on that question? This one is for both Vincent and William. What are some actions that the Navy or Pentagon could take to help shipyards build a strong business case for investment in robotic welding?
I'll speak to that first, Vincent, and give you a break there. I think there's a few different approaches to solve this problem. We have seen great success with our robotics manufacturing hub, which is basically a development lab. It is effectively an R&D center and a training center wrapped into one. We have a variety of different robots, and we can actually take the application directly to our lab and employ it there. And we basically do all the R&D. If there's any fixturing involved, any changes to end of arm tooling involved, and actually demonstrate the weld or any process for that matter in real time on the actual hardware that is to be welded. The one trick here, though, is you need to get the frontline folks involved. You need to get those welders involved. You can't just kind of bring them in at the last minute. So starting from, you have to bring in both the hardware that needs to be welded or worked on, along with the lead welder themselves, to get them comfortable with the system, to get them comfortable with the process, and use their expertise, use their art, their knowledge, their decades of experience in dialing in those heat parameters, right? And welding is just managing heat, right? So using their experience to manage that heat to get the proper weld in that controlled environment before it gets deployed out to the floor. So really taking the risk out and coming up with a solid solution prior to it being deployed to the shipyard.
And to add to that, right, I think, you know, a lot of this also comes down to the shipyards for lack of a better term, kind of forcing it, right? Today, at least at Electric Boat, we give the operators a lot of tools, which is great because there is so much variation. But it's almost a, hey, we got this system. This is the way now, right? And getting that operator buy-in 100% and getting them bought in early. But it's not just them. It's them. It's maintenance organizations. It's the management organizations. It's the equipment control organizations. And it's having a supplier that can readily provide customer support, right? So there's so many aspects of implementation beyond just the, yes, we can weld this joint. I think on top of that, it's very critical to understand the applications that you're doing, right? I don't think anyone would want to go spend $1 million on a robotic welding cell if it's only going to be operating for 10% of the year, right? So there's a lot of balancing that we have to do, and that should all come out from, I would argue, the manufacturer, the shipyard, in a sound business case, right? Why am I going to go spend this $1 million, right? And yeah, sometimes it is hard to come up with that cost savings. But I think the big thing also is schedule. And if you can be doing it faster and you can be increasing that arc time, a lot of the pitches that I've seen, we get some good questions, but ultimately, if you really divide, how many do you have to make? How many widgets do you have to make a year? You have to make 100 of them. You're only making 10. Well, a robot might not get you to 100, but if it gets you to 20 or 30, it's just one of those other things, an additional tool that can support. So I think the business cases really have to be developed based on the amount of widgets you need to do and making sure that you can have that system running all the time.
And Eunice, did you have anything to add?
I call a lot of the points raised by both Vincent and William. So one of the issues that was constantly raised was in the interviews was the issue of how do you couple all this together. And that's one issue that I think would be kind of difficult to resolve in integration. When you have various OEMs supplying these various parts, and then you don't want to be locked into any particular OEM, and you want to be free to get the best systems available. So how do you really couple them together? And many of the interviewees during the survey, during the putting together a report, looked at that as something that was a serious barrier going forward. And I think the industry really needs to get together to kind of come up with some guidelines on how they can really, I think industry organizations like American Welding Society, I think can also weigh in on things like this.
Thanks, everyone. And this next question is around Robin for everyone. How can the Navy and industry position robotic welding adoption as a support or force multiplier to the welding workforce? What training models for the workforce are most promising?
I could start with that one. I think this is going to sound like a very simple answer, and I know this is more difficult than I'm making it sound, but I think the key here is going to be two things: user interface friendliness and the ability for the welder to get on the job and start in a very reasonable amount of time. And I would argue that that is like 30 minutes, if not even less than that. If it takes the operator, going to the job and taking 4 hours to get set up, well, then I could have just picked up a hand torch. So I think that's the two critical things that we need to focus on.
William?
So
Or go ahead, Eunice.
Go ahead, Eunice.
yeah, so if I may add, so I think it might not just be the time to start, but also I think one of the considerations where the government might be able to help might be policy related. Let me just put this as a disclaimer. I'm not, even though I work for Navy, this is my personal opinion. I'm not, it's not the opinion of NAVSE or the Navy or the Department of War. So they can help through to de-risk these investments by giving some kind of tax incentives, some cost sharing, which I think is already done in some form or the other, but there can be incentivize the industry that if certain certain things are achieved or accomplished, then they get certain benefits in terms of either financial or non-financial. And I think we can go that way as well.
William?
Yes, with respect to the workforce training and everything else, I would much rather teach a welder how to operate a robot than teach a roboticist how to weld. The robots come off as very intimidating, but once you really dig in there, they're really not as complicated or, frankly, as hard to program as you think. Welding as a skill, understanding how to manage heat, torch angles, everything else is really a lot more complicated than having that robot do the work for you. It's kind of a very important takeaway, I think, is being able to educate that workforce that already knows the hard part, and then teaching them the robot part. I think it is a lot easier, and there's a lot of value there. And I think the main key to that is having the robot take away, or not having the robot support the jobs that humans don't want to do, that the welders don't want to do, whether they're ergonomically difficult, whether they're repetitive and tedious, and getting the work that people struggle to do mentally, that they don't want to do, onto the robot. They will really see the value in it. And from there, it will really take off. Once people can focus on more high value, more rewarding work, and leave some of that repetitive work to the robot, I think is where you're going to see that really multiply, and you really see an increased rate of adoption.
Yeah, and then just to add to that, right? One of the biggest things that's contagious in a good way, or could be a bad way, once one or two or three operators latch onto it and spread the word that they're enjoying it and using it well, that's positively contagious. If they get the opposite reaction, it is very toxic very fast. And I totally agree with you about needing to train welders how to use a robot, not a robot tech how to weld. But the problem that becomes is a lot of people, I think, are selling these systems as you could take someone off the street who doesn't know a robot and doesn't know how to weld, and they can do it. Again, these robots will put down a very nice weld bead, but that doesn't mean it doesn't have lack of fusion underneath it. It doesn't even mean it's in the right joint, right? So one of the other problems right now, and Eunice, you hit on it, is the lack of skilled workforce. So I think everyone has to be rational that, this robots aren't going to fix both of those problems, and you need to have that skilled welder on that robot.
If I may also add, in the interview phase, one of the interviewees mentioned that they are subcontractors to the primes, and in the past they do have programs which the primes sponsored by align them. They do have demonstration centers or demonstrations where they invite their subs to send in their welders to come and learn some new techniques, and that has really helped them. So I think that's also another way forward in terms of if you're trying to get robotic welding, get the industry to use it more. These primes have that financial muscle to be able to afford this equipment and also organize training for their subcontractors. So if we have that kind of industry-wide process, then it might help those at the downstream end of the industry getting more comfortable with robotic welding.
So the next question, if a person had no welding experience at all and came to work at the shipyard and was given the opportunity to develop the welding capability with using a robotic welder or just using the traditional style of welding, how would that look and what would be superior?
Yeah, so I'll take a stab at that one. Someone to repeat your question, someone coming off the street, no robotic experience, no welding experience. How long would it take? Is that really the crux of it?
Yeah, and which would produce the better outcome?
Yeah, so someone coming in off the street, right? We'd first have to understand, okay, what are they going to be welding, right? Are they going to be welding some thick section volumetric joints? Let's go down that path, right? Let's say that's what they're doing. Off the bat, they should just they would have to go through the weld school, right? And they'd have to go get some experience out on the floor. I wouldn't want to throw them right on a robot. I want them to, for lack of a better term, feel the pain of getting that manual experience, really learning what they can do, probably getting at least 6 months of experience. Past that, everything that we've seen with training operators on cobots, for instance, welding cobots, if you're going to be doing some complex geometry, thick section welds, it's taken anywhere between 2 to 3 months to get someone up to speed and proficient. Proficiency there is the key, right? An old manager of mine used an operator qualification analogy. Is the same thing as getting a driver's license. When you were 16 or 17 years old and got your driver's license, you weren't a very good driver, but you can get to point A to point B, right? But you couldn't get in a Formula One car day one. You have to learn that, and you have to get up to that experience level. Welding is very similar in that regard.
Yeah, I think Vincent really hit the nail on the head. Yeah, we've seen situations where people without welding experience, they weld things, they weld components, and there's no way you're going to accept those. The experience is highly needed, and getting people to actually learn it and proceed to robotics, it's like even trying to apply AI today. In whatever field you are, for you to even use AI to the most benefit, you need to know your job. You need to know what you need to have that knowledge base in your background area, and then you can now build on it. So I think it's the same thing with robots. You using robotic welding, you need to have that basic knowledge of welding and that practical and theoretical knowledge of how to do good welding, and then you can build on it with robotics. Over.
Yeah, I wish I could present a counterpoint, but I agree with both Dr. Balogun and Vincent. You need that hands-on, arc-on time to fully understand the welding process before you're handed a robot.
Thank you. Next question this actually is for Eunice. And as always, anyone else can chime in. From a national security perspective, what risks does lagging in automation pose to U.S. Navy readiness, especially as adversaries invest heavily in this area?
Thank you. So currently, China, let's start with that. In a report sometime last year, the Center for Strategic and International Studies published a report in sometime March last year, in which they looked at how China is doing with the adoption of robotics in robotic welding shipbuilding. So they stated that commercial shipbuilding, China already has their output is about more than at least 60% worldwide output for commercial shipbuilding. And shipbuilding generally overall is more than 50% of the world output. And they looked also at naval combatants. For every 6 that China produces a year, the US produces about 2. That's surface combatants. And for submarines, for every 2 they produce, the US produces about 1.4. So that just to tell you how dire the current situation is. So from national security perspective, with China selling so much to even our allies in terms of like commercial ships. Now, China has a dual use policy. That means their shipyards produce for both the commercial industry and the military. What that means is in a wartime scenario, they can ramp up shipbuilding very quickly. And what is really aiding them now is they are aggressively using automation in their entire system. And that includes robotic welding for shipbuilding. And given our current state of welding for naval shipbuilding, even when it comes to repairs in a wartime scenario, we find it difficult catching up. And not adopting robotic welding and just as we at the current state, costs also increase. And we also know the current workforce is aging. And if you don't have a pool to replace them quickly, then the situation will get worse without actually using robots to accelerate the work, expedite work, and get those who are the current welders to, you can make them do high value work where their skills are better used. So it's also a situation, it also has to do with logistics as well. As our allies, most of our allies, they also buy from China. In a wartime scenario, you have that logistic problem where how are you going to do the support logistics? If our allies also depend on China. And also there's this convergence of robotics, artificial intelligence as well, and then digital twins for high complex manufacturing, such as shipbuilding. If you are not combining all those from now, that means we'll be far behind. So there's that innovation will be lacking down the road. So we are, in essence, ceding a technological and industrial advantage to other competitors, and is a very serious security, national security issue. Over.
Thanks, Eunice. Did either of you, William or Vincent, have any thoughts on that? No. So, what level of adoption for robotic welding in shipbuilding do our allies possess?
So on that point, let me quickly mention during this, in our review of the literature, they are not as aggressive in their adoption. I mean, in European countries, they are not as aggressive as the Asian countries, Japan, South Korea, China. From what we found in studies, they are just in moderate adoption mode right now, and there are still some ways to go compared to the Asian countries. Over.
Thank you, Eunice. In the current Navy shipyards and shipbuilding, where has the adoption of and the success of robotic welding been most noticed, most well accepted and successful?
Yeah, so I could take a stab at that one. So I want to break it down for everybody into two real categories. You have industrial type robotic systems that are designed to stay in place and you bring parts to them, right? Very specifically designed systems. And then you have welding cobots, which are more of a universal thing that could be used on various different parts. So historically, at Electric Boat, a lot of the initial use cases were with industrial systems, right? Because cobots are rather new to the industry. So where some of our industrial systems have been received well is when that was the only option to do the joint, right? So the joints and the sequence was designed specifically for that system. One of our major modules uses robotic welding on very thick section stuff, and that was kind of one of the first heavy section robotic welds that worked very closely with the Navy to get that working, and that's something where we are seeing benefit. We've had other industrial systems since then, and I think the big key is going to be your fit up and your repeatability. So one of the big things that we're moving towards with robotics is cladding, because that's a high deposition area and it's repeatable boat after boat and piece after piece after piece, right? And I think I want to add another little point to this, right? We've been talking about robotics, and robotics are going to increase your efficiency, increase your arc time. But I think the real crux of what we want to do is automate things. And if you partner with some of the good integrators that are out there, they'll come into your shop and they'll tell you that they could automate or put a robot on everything. But coming up with that business case, and you might find that, hey, I could just go get a boom arm and mechanize this for a tenth of the cost than just getting a robot to say I have a robot. So I think the real drive here should be automation, right? Getting the torch out of the welder's hands and really increasing there, because if you already have a process that's doing automated welding, going to robotic, really, I don't think I've seen real gains in it getting you something.
Thank you. A question from one of the attendees. Does the new generation of LLM or thinking LLM agents have any potential application for robotic welding? What AI breakthroughs will you be looking for?
Yeah, I guess I can speak to that a little bit. Yeah, large language models, AI, image recognition, certainly will add value as we move forward in this industry and as that industry matures. Great example is seam tracking, to being able to follow that seam in real time to close the loop with your torch with respect to where your seam is in real time and be able to increase the quality of all of your welds. So there's a lot of potential there as an easier one. If you kind of expand beyond that vision and into general inspection, you can even fold that into a real-time inspection. Think a thermal imaging camera to monitor temperatures, puddle size, pool flow in real time. So utilizing some of those algorithms really to close the loop on, in addition to some of the technologies that are out there now, I think will really improve quality and eventually adoption, obviously.
Yeah.
Anyone else? Go ahead.
Yeah, so I think there's potential here, just as William mentioned. Those are some good examples, and I also think there is potential for like post-weld inspection too, where you can have lasers kind of do some dimensional measurements, which we currently do manually, and that way you can avoid having to do visual inspection after the welding. So some of those can be incorporated into the quality process. As, of course, we already mentioned in processing inspection, where you get in process that for like heat input and interpass temperatures and things like that.
Thank you, Eunice. So the next question, how has the actual robotic welding capability evolved? Where are its shortfalls? And then what direction in evolution is needed for increased adoptability?
Well, I would say that robotics have come a long way over the past 10 years. I already kind of mentioned some of the things as far as going from actual writing code to now being a more user-friendly type user interfaces. I think there are still some, I'll call them shortfalls of it, right? Because where we really would want to go, I would imagine, as an industry is kind of that full-blown lights off automation. And what I mean by that, because everyone has their own definition, is you put the part in there, or you bring it to a part, you press go, and kind of like an easy bake oven, you come back in 20 minutes, 2 days, whatever it is, and it's done, right? So you're having that system do everything. But also, a lot of the things that are developed in labs or in, robotic developers, they aren't necessarily getting the shipyard atmosphere, right? Or the shipyard conditions. So William, you mentioned seam tracking. It's a great technology, especially when the part is sandblasted. But if it's buffed, or if it's shiny, or if it's ground in different orientations and directions like we see in shipyards, that's where sometimes that seam tracking, that laser tracking doesn't work as well, right? So how can we get the lasers better? Do we have, preheat and interpass monitoring, just like Eunice was saying? Do we have, inspections? Do we have real in-process monitoring? All kinds of different things I think we can get there to really get that full, automatic robotic systems. Whereas today, a lot of them still require a lot of user input. And I think some of the tools are there for some of the joints, but I don't think they're fully there yet.
And William?
Yeah, and Eunice spoke to digital twins earlier in his presentation, and they certainly add a lot of value for offline programming and getting your paths correct, even order of operations, number of paths, and everything else. And that's great, but there's still a big discrepancy between what happens in your simulation and what happens in real life. And being able to close that loop and getting more realism into those digital twin models, I think will really help a lot in enabling a lot of that technology as well.
Thanks, guys. Next question from the audience. Are there limitations related to precision parts or specialized materials where robotic welding systems may be less effective?
Overall, I would say it all depends on the welding process, right? So I think if you could weld it manually, you should be able to weld it with a robot, right? And you'd pick the right process to complete the job. I think that's just... William, would you agree?
Yeah, no, I agree. I think you'd have to be able to do it manually prior to automating it, much like we talked about before.
Okay. Next is one of the missed answers in having multiple robots, large scale factories, is creating huge replicability of components to advanced defense manufacturing capability. One robot, little value, 10,000 robots equals 2 extra ships a year. it's not that simple, as it will require work, but if definitely the next logical progression.
Yeah, absolutely. And I think to harp on one of the other questions that's in the chat here too, right? Talking about retrofitting existing areas. Right now, a lot of the shipyards are old throughout our country, and a lot of them are jam-packed to get the job done. So if you have to go retrofit a 5,000 square foot area and it takes you 6 months to do it, you're not going to be able to install those systems. And are you able to eat that 6 month of schedule loss? So I think there's a lot of value in having robotic systems scaled. Totally agree. Having one is not going to get you there. You got to scale it. And I think there are going to be growing pains in that scaling, but you have to find out where that cliff is and be able to go.
But I think on that issue, it might depend on the size of the organization of the company we're talking about, whether it's a prime contractor or a small scale subcontractor. So in the course of this putting together the report, in the interviews, there was a particular subcontractor who said they do precision parts, and they've been very successful with just using a robot on that. So that way they were able to use their skilled welders to focus on other high intensity jobs. So I think they were very successful because just focusing on that specialty part that we are producing for a prime, they were able to accomplish it with robotic welding. And I think there is value also in that. If every organization thinks of, or that wants to adopt, think of how best they can use robotic welding, there might be value without having to do significant ROI. I agree, for primes, they have so many things that they have to use robotic welding for, but it might not be the same for subcontractors. So I think it's company dependent, let me put it that way.
Next question. Oh,
Yes,
go ahead.
yeah, sorry, last comment on that. Maybe I don't fully understand the question, but I think the key is to start small, right? You start with one or two robots and you gain the confidence and you gain the learnings prior to multiplying that up to a large variety of robots. I don't think we go from where we are now to 10,000 robots in a shipyard and expect much benefit. I think it's a slow ramp up and building of confidence before we get to that point.
Thank you. Next question from the audience. What is the most appropriate vehicle for this effort? Navy Mantech, IBAS, or another mechanism?
I mean, you hit on a bunch of different funding sources. It depends on what you're really looking for, how much money you're looking to get. Are you getting something right off the shelf, or are you wanting something that's a more specific built? So sorry for the kind of lame answer, but it depends on what you're looking for.
I think each of them focuses on different aspects of the transition stream. So Mantech maybe probably not fully developed in terms of the R&D level. It might be just the scaling of the technology. IBAS might be maybe deployment. So not very sure exactly, but it depends on at what point in scaling of the technology that you are, where you have to use either of those funding streams or funding programs. So they cater to different aspects of the R&D phase of the technology.
Okay, and we're we're starting to press up against time. So I had a kind of a, I'll say a closing question for each of you. So where we're at today, in 5 years, where will we be seeing the adoption of robotic welding in Navy shipbuilding?
So from an electric boat perspective, we're really focusing on having very sound, clear business cases on repeatable work. Right now, we have a very large effort to go get a bunch of systems that are already in the process of being procured for a lot of our surfacing applications of different components. That's going to be the big one that is repeatable day after day after day. And we're going to have a whole line to go do those things. I think we also have some efforts in just really taking a step back and looking at all the different components and parts and pieces that we can go turn into more of an assembly line type process and see the benefits that we can get from automation.
I would say in 5 years, there should be some significant progress in adoption, given the fact that the Naval Shipbuilding, the fleet demands, there is that fleet demand that is going up. We want to build more ships, and the industry seeing that, seeing how serious the government of the day is in terms of building more ships, I think they'll be interested in trying to really scale up and use robotic welding, because the current timelines that we are seeing in ship delays and exploding costs is honestly unacceptable, and I don't think that will continue down the road. So 5 years from now, I would say we see a big jump from where we are today. Over.
Yeah, no, I would certainly agree. And I think a lot of that change is going to be in the entire process. Not just on the robot implementation, but on the process, how those parts are prepared for the weld, how those seams are ground, how the fitment goes together. And that whole entire process needs to be built prior to automation to make sure everything's consistent, to really make that robotic application a lot more successful and repeatable, much like we've seen in the automation industry over the last 40 years, is getting those parts designed to be manufactured.
I see. I have time for one more question, I think. Is there a place today, whether it's within the shipbuilding community, like Electric Boat, or within the government workforce development, can somebody just raise their hand and say, I want to become a welder and learn how to become a robotic welder? Does that capability, facility, kind of pathway exist for people looking to enter the workforce?
Yeah, I would say that it does. Historically, and what we've been doing, right? With the first few robots, it was okay, go get the best welders. This is the first time we're doing it. Let's have the best welders really learning this stuff. But then in recent history, right, we've had a little bit of different take on that, because there are some people that are really good welders. They know how to weld, and they just want to learn robotics, right? They're like, I don't want to have to hold the torch. I want to learn this, and they're dedicated to learning it. So I think it depends. And a lot of the times the operations management will go around and they'll say, okay, is anyone interested in this, right? Sometimes you're going to be voluntold to do things, but it's always easier when people volunteer. And there's definitely the spark with some of the newer welders of wanting to get in this realm.
Yeah,
think-
my advice there, there's certainly avenues to do that. Like we touched upon earlier, get that Archon manual training first, understand how that whole welding process works, before it gets applied on the robotic side, and then brush up on the robotic skills. Like I said before, it's a lot easier to teach a welder how to use a robot than it is to do it the other way.
Eunice, within the Navy?
I think there's been growing interest in getting people, even from high schools, to go to 2-year colleges to go and to learn robotic welding. And also there's been some funding at those levels to also help train robotic welders. So I think there's progress ongoing.
Great. Well, I see Arun's on, and that's our signal.
Yeah, I'm the
So
gong.
thanks to everyone for their participation.
Well, I
Thank
want
you.
to thank Jim and the panelists for that great and insightful discussion. It was a nice discussion of the promise and the potential for both industry and the Navy, as well as thinking about the challenges and ideas on how to overcome them. It's something that I think we at NDIA and ETI want to continue thinking about. So anyone who wants to continue this discussion and maybe move forward with some of these ideas, please reach out. I also, of course, want to thank Eunice for the great presentation, his time at NDIA, and the report he produced. The link to that report is in the chat. If you have feedback about this event, please email us at eti@ndia.org. I want to take the opportunity to highlight a few of our upcoming events. So on January 28th, from 1 to 2 p.m., we're going to kick off a new 4-part webinar series called Digital Transformation for Acquisition, or DXA. It's going to be looking at how digital tools and approaches can help the Pentagon drive faster acquisition processes. This is the first webinar of that new series. The second one will be February 11th from 1 to 2, where we're going to hear from program managers about how they've incorporated digital transformation across their programs. On February 18th, we're going to be hosting a webinar in partnership with MITRE, and we're going to be discussing the use of cutting-edge AI-enabled market research tools to support the mandated work of the acquisition workforce. And our next Tech 101 webinar will be on February 24th. It's going to be on agentic AI, so be on the lookout on NDIA's website, calendar events, for more information on that. To register for these and other ETI events, please visit ndia.org/events. And again, go to our ETI website to see all of our reports and information about our podcasts and our conference. Thanks again to the panelists, to Jim and to Eunice, and thanks everyone for joining us today.
Thanks, Arun.
Thank you.
Bye, everyone.
Bye.